I am here to talk about Microsoft Graph. Microsoft Graph is the gateway to data and intelligence in Microsoft 365. Microsoft Graph provides a unified programmability model that you can use to take advantage of the tremendous amount of data in Office 365, enterprise mobility, security, and Windows 10. So I put quotes around that because that's what Microsoft describes this thing as. So specifically, I'm mostly just going to be talking about the Windows 10 side of this, and just a little bit about OneDrive as well. First specific feature that comes out of the Microsoft Graph that I care about is a brand new feature in Windows, and it is called Activity Feed, or rather in the cloud it's called Activity Feed. On your desktop Windows, in the latest version of Windows, it's called Windows Timeline. So the Activity Feed is basically your interaction with your computer and all the things that you have done that have been recorded either by third parties to the Microsoft Graph or by Microsoft locally on your machine, as long as you have it turned on, which it's on by default. What does that thing look like? It looks a lot like this. In this case, you can see all the things that I've been working on. They look kind of like what you'd probably expect me to be working on. Lots of Harmony Core, some PowerPoint, and runtime related things. So the way you can see this thing, so this is my machine at work. So this button down here in the lower corner, right next to the Cortana box, brings up the task switcher. So it looks like that screenshot, more or less. Those are all the things that are running on my machine. And you can see this thing over on the right, and that's basically rolling back through history, through the things that you've done on your machine. So that's what the activity feed actually looks like. So things that you can use the activity feed for. I mentioned that third-party software can interact with the activity feed through the Microsoft Graph. You can use it to record single activities or to group related activities and user actions that your application has performed. So if someone's editing a document or a group of documents, you can put those into a single entry and put them out in the graph so that they know on any machine that they log into as their user, this is what I was working on, and I can go pick up where I left off. If the same item changes a whole bunch of times, you don't keep putting it into the graph repeatedly. You can attach history items that keep track of the user has been working on this item for the last 6 weeks, 6 months, whatever. And so you just keep appending history items to it whenever they do some significant chunk of work. Because this data is stored in the cloud, it can enable you to support cross-device activities. So imagine there's a lot of you that have mobile device apps or websites that are designed for mobile users in addition to your desktop applications. So you can sync those up, right? If they're doing something on mobile, you can be storing that information in the graph and then taking advantage of it when they go back to their desktop, and vice versa. If they're doing something on their desktop, they can pick up where they left off on their phone. So one of the many advantages of shoving data into the cloud. Don't use activity feed like this. Do not create user activity for actions that users don't need to ever come back to. You're just going to clutter up their timeline, and they're going to hate your feature, and they're going to ask to turn it off, and they will miss whatever value you actually ended up delivering because there's just a whole bunch of noise that they never ever needed to see that stuff ever again. Don't ever create user activities for things other people do. So if someone else has done something, don't fill this other user's timeline with stuff someone else did. It's not for that. Use some other mechanism to do notifications. This is specifically so I, as a user, can know what I've been working on from device to device, and I can come back in and pick it up where I left off. Right, so how do you actually pick up where you left off? You have to come up with some kind of unique ID for the activity. That might be like a file name, that might be some kind of record locator, that might be some kind of transaction ID, some way that you can figure out what they were looking at preferably not just on their actual desktop. So that locator needs to make sense to all of the places where this user could interact with your application. So it needs to be a unique ID, and you may need to come up with some kind of mechanism to store actual unfinished work if you want to take advantage of it for specifically coming back into an unfinished operation that the user was working on. So you're probably thinking to yourself, the cloud now knows everything about me, and are people able to just get at that? Are third-party applications able to just go read all of the things that I've done? Security is important. Security matters. The first steps in interacting with the graph on this is you have to register your application. So I have a URL here. Basically, you just register your application's name and some other information, and they give you back some tokens and or secrets, and some instructions on how to use OAuth to actually sign in as that application. The next step after you're registered is you have to actually do authentication with OAuth 2. So the user has some kind of username and password floating out there in the cloud somewhere, because we're talking about the Microsoft Graph. They've signed into Windows somehow, and you want them to sign into the graph and give you a token that says, yes, there's a scope of work that I'm allowed to do on behalf of this user inside the Microsoft Graph. Give them back a token so that they can actually use it. And you're going to have to declare what you actually need to do in the cloud. And the user, when they give you that token, they're going to be told what you're asking for permissions to do. So if you ask for permission to do everything, they're probably going to wonder why you want permission to unlock their house when you're supposed to just be adding an item into their activity history, right? So don't ask for the entire world worth of permissions. Be very, very specific about the permissions you're asking for, whether it's read-only permissions or read-write permissions, and how siloed it is in terms of the narrow scope that you're asking. You've sort of seen a similar slide to this yesterday when I was talking about OAuth flow. This is just walking through the slightly more in-depth flow of it on the left, and a more general flow for two of the different flow options, because there's different ways that you can sign in with OAuth 2. There's several different, completely different flows, whether you're an actual end-user application that's trying to do authorization, or whether you're a web service that's trying to do authorization, the flow is very different. So keep that in mind when you're actually setting things up. So inside the actual activity feed, so you see the little squares there, those teal-looking things? Those are cards. So they're called adaptive cards. And the way you create those adaptive cards is with a small JSON document. You basically outline all of the elements that you want to have displayed, and there's a bunch of different schemas that talk about different kinds of cards. So you pick the general kind of card that you want, you put in the information to that card that you want, and then it gets rendered by some sort of host application. In our case, what we're talking about is having Windows as that host application, because it's rendering the card for you in your timeline. This is useful for other things, though. It's not really graph specific, but adaptive cards are obviously useful inside of Windows. They're useful in things like Skype and Slack and inside Cortana and email clients. That's actually probably the most directly useful thing, is you can send adaptive cards that are interactive through Outlook. So here are a couple of simple examples for adaptive cards. You can see the upper left-hand corner one there is interactive. That's actually an Outlook adaptive card, but you are determining what the layouts are almost entirely, and you can put images and text and all sorts of good stuff in there. But they are constrained because everyone has to be able to render them. There is a whole lot of different tooling around adaptive cards. There's 2 different authoring SDKs. One of them is in .NET, and one of them is in JavaScript. And then there's a bunch of hosting SDKs. So if you have a UWP app, there's a hosting SDK for you. So you can just tell it, here's an adaptive card, I would like you to go render it for me, please. If you have a WPF, HTML, iOS, Android app, you can have it render live for you inside of your app native using the SDKs. As a fallback, you can use the .NET Image SDK hosting APIs to generate image versions of an adaptive card. They are no longer interactive. You can only render them once and then push them out to the user, and they see what that adaptive card is, but they can't, there's no interactivity in that model. Also, there are some relatively helpful tools at the link that I have here for adaptivecards.io. That is a visualizer, so you can put in the adaptive card JSON that you've come up with, and it will render it for you in the various native apps and tell you what it's going to look like if you actually use it. The next part that you actually have to use in order to make the timeline stuff work is you need protocol handlers, and I'll show you why you need protocol handlers. So we have an internal application. I'm sure you guys have all heard the name. It's Tracker. It's where we track our bugs. And what I made was Tracker now produces user activities when you create a new tracker or do something to an old tracker. It'll put them in your timeline so that you can come back to it and see what you were doing and resume whatever you were working on. So this is one of those user activities that's from Tracker. And I clicked on it, and it launched Tracker. So you're probably thinking to yourself, like, how did it know what I was supposed to launch? Did he just embed the exe name for DBR somehow into this timeline thing and make it go launch Tracker? I didn't. That would be crazy because I have no idea where Tracker is installed on your machine, so that wouldn't do me any good. Plus, this thing is supposed to work from one device that's Windows to some other device that's maybe not Windows. And if I was actually taking a hard dependency on some executable, that would not work out very well at all. So the way Windows figured out that I wanted to launch Tracker, which is a DBR program, FYI, was with a protocol handler. So protocol handlers are a concept in Windows, and they've been around for a pretty long time. You can see the date on my URL here is from 2006, and I think they were actually pretty old when this blog post happened. So they've been in the product for a very long time. But you can register a custom URL protocol handler. Essentially, it's like HTTP. If someone tells Windows, please go open me something with the protocol HTTP, it'll pick your default browser, and it'll pass that URL along to it, and your browser will show that URL. Protocol handlers do that, but for your protocol. In my case, I made one called Tracker. And then the URL that gets passed to Tracker is the tracker number that I'm trying to load. There is a very important caveat with protocol handlers that you cannot register the destination for a protocol handler to be on a mapped share. It has to be local to your machine, or they will not launch it. There was a lot of frustration and maybe some cursing at Microsoft when I realized this, but you have to be, whatever you're launching needs to be local to your machine, otherwise it will not launch it. A hack around to this idea is a batch file that's local that kicks out to something on the network, because they don't watch your process throughout the history of it getting launched. They will happily launch that local batch file, and that local batch file can go launch whatever you want it to launch and set up whatever environment you want, but the batch file needs to be local or they won't call it. The next step, because Tracker is a DBR, so it's a Synergy program, my use case was when I click on that user activity, I want to load a particular tracker inside Tracker, and show it to the user. I don't want them to have to do a bunch of different steps in order to get there. I want to click on it and go straight to what they're asking for. So the concept for that is called deep linking. And the idea is that you have some kind of command line argument that gets passed in that says, I would like you to read this command line argument and take me to this spot inside of my app. I know some of you do this already as a way of interacting between the different parts of your application. But in my case, Tracker did not have that functionality, and so I had to build it using CMDLN. So you take those arguments, and then when you read the argument that's saying, I need to do a deep link, you actually navigate to whatever internal state that's required in order to get there. This stuff is the Microsoft Graph, so it is a REST API, so it's a RESTful web service. It happens to, in particular, be an OData RESTful web service. So it's very similar to the Harmony Core web service that we've been talking about and we'll be talking about again tomorrow. So you can see in my large Git example that I'm using a filter for the history items, and I'm basically bucketing it into I want to see the history items that start here and end here, and nothing else will get returned from the API. The full set of operations that you can do that you mostly care about is if you are writing your own activities, you will have to call that put call that is to /me, which is basically talking about the logged in user, activities, and then your made up activity ID that is unique. If you want to use it on some other device, on say a mobile device, to actually show what that history list is, you would probably end up using the get entries. And if you think the user doesn't care about this activity anymore and you were the one that put it there, you can use delete to get rid of it. So because put is important and there's a bunch of data that you're supposed to send across, I have included an example here that's very similar to what I actually ended up doing with Tracker. So I came up with a unique ID based on the program name and the tracker number, which is relatively unique, I hope. And it gets formatted as JSON and posted to this URL. And that actually adds the item into my activity feed. So you can see the schema type that I've actually chosen is a write action, and I gave it an author and a name, and then the visual elements is where you define how this thing is actually going to look, and if you weren't using Timeline, how you would be able to interact with it. Timeline is not an interactive adaptive card, it's a purely displayed adaptive card. Device relay. So device relay supports sort of similar scenarios, but kind of more explicit and also more in preview. So if you think to any really good sci-fi that has people walking around with some kind of magical futuristic superphone-like device in their pocket, and they walk up to some wall that suddenly turns into a giant TV screen, a lot of times they'll like pull their whatever super phone out and like fling their finger at the wall, and all of a sudden the whole user interface gets taken over by what was previously tiny and on their phone. The idea for device relay is basically like, let's do that. That'd be cool. We should really get on that. It's an explicit mechanism for transitioning a user from device A to device B. So essentially, both sides are either always watching the cloud for push notifications to say this is the activity that I'm supposed to perform, or on the sending side, you're calling a REST API that says, I would like to transition this to some other device. Please send this message to them and get it delivered. So that is currently in preview, and there are cross-platform interfaces for it for iOS, Android, and Windows. And the fact that it works on Windows means that it also works on things like a Surface Hub. So we're rapidly getting closer to that sci-fi goal of having a giant wall with a TV screen that you can just fling your application onto. OneDrive is also in the cloud. So everybody's in the cloud, but specifically, because I'm talking about Microsoft Graph, OneDrive is in the cloud. And it is, again, a RESTful web API with OData. And you can do a whole bunch of stuff with it. So users have files, they have drives, they have folders. You can enumerate those things. You can add things to that list. As long as they've given you permission to do it, you can interact with the full contents of their OneDrive, or a limited subset of their OneDrive. Because this is so very similar to the rest of Windows, there are special named folders. Think like documents, downloads, My Music, the sorts of things that you have on your computer. They have special named folders in OneDrive that you can access, and also the users. One of the other useful things, because we are talking about business software in this room, I think mostly, right? People have various contacts. So instead of having to kick them out to Outlook or something like that in order to get some contact, or show a list of contacts or a list of people that care about something, you can just go ask the Microsoft Graph, hey, can I get the list of contacts for this user that's logged in? And you get back an answer. You can also do sort of clever things. Again, because it's an OData API, you can filter those contacts by doing things like, hey, I want to get all the contacts where the address ends in some particular domain. And then the API will go out, do that operation, and give you back a list of all the contacts that are for that specific domain. And here is an example response that includes things like their birthday and display name and given name and initials and those sorts of things. I've been mentioning it as we go along, but Microsoft Graph is an OData provider. You can use the Graph Explorer to interact with all of the APIs that they provide, which is a pretty large list of things. And when you're in the Graph Explorer, or anywhere else for that matter, you can play around with the OData queries. So all the sort of normal OData query operators are supported. So you can use top and skip and very complicated filters and select and order by and expand, and you can walk your way through the graph that way. Some of their examples use a slightly different URL convention called key as segment convention. But they also work with the parenthesized variants that Steve and I have been showing you examples of. So you can keep that in mind. Where can you use this? So all of this stuff is a REST API. And traditional Synergy has HTTPS API, and it works great with all REST APIs. So you can use that everywhere Synergy runs. There are also .NET SDKs, and those are usable anywhere .NET Core or .NET Framework will run. The .NET SDKs just give you strongly typed classes and methods that you can interact with for the various endpoints. So it just makes development easier. So I have a couple of additional links here for you to take a look at, specific to the interesting things that other people have presentations on, or videos on, or Stack Overflow questions and answers for the various topics that I've talked about, as well as AdaptiveCards.io, because actually, choosing how to format your activities is a very important part of getting the users to care about what you've presented them and find what you're presenting them to actually be useful. Are there any questions?
What contacts does the Microsoft Graph API retrieve? So if I have my contacts in Gmail or Outlook, does the API retrieve them, or do you need to export to Microsoft Contacts?
So the contacts list is a Office 365 functionality. So it's specific to the email addresses that you would have from like Outlook or something like that. It doesn't really know anything about Gmail. I think you could probably, there's a similar API for Gmail, but there's not a unified answer to that question that I'm aware of.
All right. Thank you, Jeff.
All right.